Alright, trying to move quick once again today. This is 11.5 using intercepts. How do we graph lines? Well, the first method I told you to use, which you can use for, hey, down here in the corner, you can use that method, making a table of values, to graph really big, complex, complicated equations that are like way beyond you right now. So that's a tried and true method I always come back to. Make a table of values. Choose some x inputs, find out what the output is, plot those points, there you go. But there is a trick here to use intercepts. What does that mean? Well, look at my graph right here. Here is a graph, y-axis, always the vertical line there, x-axis here. Now y-axis and x-axis, this is different than y equals 1, right? Or x equals 2, which we found out yesterday were kind of opposite. Anyway, if I told you, hey, I don't know how to graph this line, but I know that it goes through 0, 4. I don't know the equation of this line. I don't even know how to graph it. But I know that it goes through 0, 4, and it goes through 1, 1, right here. 1, 1. And know it's a straight line. It's a linear equation. I'm sure it's a straight line, but I only know these 2 points. Could you draw on my paper right here in this video? Could I draw a straight line through these 2 points any other way than right here? Is there any other straight line I could draw through those 2 points? No, there's not. So, if you know, by the way, this word intercepts, you need to know what this word is. An intercept is wherever a line intercepts an axis. Using intercepts. What is an intercept? It's where a line crosses over or makes an intersection with an axis. Okay, so this is what we call a y-intercept. Why is it a y-intercept? Because it's intercepting the y-axis. Is this an x-intercept? No, it's not intersecting the x-axis. The line will right here, but this point is not an x-intercept. Let me do a different one here. 1, 2, 3, 4, 5. This is -5. Here, let's say, is an x-intercept. And here's a line. Alright. If I told you, hey, the intercept is, or the y-intercept is 0, 4, and the x-intercept is -5, 0, can you graph the line for me? Yeah, you would just plot that intercept, you'd plot this intercept, and then you'd connect the dots and make a line. So that's all we're doing today. Let's see how we do this. They're basically explaining to you here what I just showed you. X-intercept is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. Okay. Now, you need to be able to take an equation like this one down here and find what the coordinates are for the y-intercept and what the coordinates are for the x-intercept. And here's how you do that. They tell you right here. To find the x-intercept, substitute 0 for y into the equation and solve for x. And conversely, remember I used that word last time, to find the y-intercept of a line, substitute 0 in for x. Okay, that maybe sounds a little bit confusing right now, but let's try this. Okay, let's take a look at this equation down here. Where is this? Because this I know is going to make a line, and that line is going to go on for forever, and it's going to cross the y-axis somewhere, and it's going to cross the x-axis somewhere. If I want to know where it crosses the y-axis, okay, I'm going to put a question here on the y-axis. I would know that the coordinate and the coordinates are always x, y, right? Some number, some other number. It's always in this ordered pair, x, y. Whatever points is the y-intercept, it could be any one of these points I'm drawing here. Whatever point, what is the x-coordinate always going to be? The x-coordinate is always going to be 0. Because each one of these points has not moved off of the y-axis at all. This one would be like 0, 1, 0, 4, 0, 7, 0, 10, or whatever. Right? 0, negative 2. The x-coordinate would be 0. So how do I find the y-intercept for this equation? I say, hey x, I'm going to make you be a 0, and then you're going to tell me where this is going to intercept the y-axis. Okay, 1/2 times 0 is 0, leaving y equals negative 5. So, now I know it's basically making a table of values, right? Except we're only doing 2 of them. So it's kind of easier. The x-intercept would be, we're doing y-intercept right now, right? Y-intercept, x would be 0, y would become negative 5. So I'm going to put down here 0, negative 5, maybe right here. Okay? Now looking at this equation again, to find where the line is going to cross the x-axis, which is this axis, is the y. To find where the line is going to cross this one, we know it's going to cross the y right here, but we don't know if it's going woo that way, or maybe steeper this way. We don't know. Sorry, you can't really see that very well, can you? In order to find where it's going to cross the x-axis, we're going to set y equal to 0, because anywhere on this x-axis, y is always 0. You haven't gone anywhere vertically, you're just moving horizontally. So, let's take our equation again and say, hey y, we're going to make you a 0. We still got 1/2 x minus 5. So, now we just got to do some math here to find out what x would be. If y is 0, what's x going to be? So I'm going to make a little coordinate over here. We don't know what x is, so I'm going to leave that blank. And then y is 0. We're going to find this x-coordinate. Let's add 5 to both sides, equals 1/2 x. 1/2 x, we're going to divide by 1/2, which is the same as multiplying by 2. So 5 divided by 1/2, same as multiplying by 2, so 10. I can check that because 1/2 times 10 is 5, 5 minus 5 is 0. Okay. X is 10. So back to our little graph here. This is our intercept, 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 0. Nowhere in the y. That's our x-intercept. This is our y-intercept. Plotted those 2 points. We didn't have to make a table of values with like a bunch of different points, did we? Just had to find 2 important ones. The x-intercept and the y-intercept. What do you think about that? I hope you find that somewhat intriguing and somewhat simple. Let's do, here, look at an example or two, just to make sure you got it. So, graphing. Yeah, we just did that. Graph the line with an x-intercept of negative 3. Okay, so if it tells you, that's just, hey, x-intercept is negative 3. Go to the x-axis, find negative 3, and put a point there. Y-intercept is 2. Y-axis, positive 2 is up here. There, got 2 points. Draw your line. All you need is 2 points, right? So, could you, for any of these, could you find out what the intercepts are? Well, to find the x-intercept, you'd say, hey, y, you're going to be 0. Now I'm going to find the x-intercept. Do the math to find out what x would be. Or, hey, x, you're going to be 0, because I'm going to find the y-intercept. So I'm going to find out what y would be. Let's look at this example here. Pamela runs and walks with her dog on a trail. It's 8 miles long. She can run 4 miles per hour and walk 2 miles per hour. Okay, So she can run pretty fast, walk pretty slow. Okay. She's going to do some running and some walking, sounds like. Graph the equation 4x plus 2y equals 8. X is the number of hours running, and y is the number of hours walking. Okay, so 4 miles per hour if she's running, plus 2 miles per hour if she's walking is going to get you a total of 8 miles. So if she does a lot of running, she doesn't really have to do much walking. And if she does a lot of walking, she doesn't have to do much running. You could have multiple different combinations of walking and running, couldn't you? Multiple different solutions of this equation. What do the intercepts represent? Wait a second. Let's find the x-intercept first. Okay. To find the x-intercept, let y equal 0, and then you're going to solve for x. So if y is 0, that two term is gone. 2 times 0 is 0. Divide by 4, x equals 2. What does this mean, though, class? Can you actually take a moment with me here? And can we figure out, okay, we got these equations, these numbers, and some girl named Pamela. Cool. What does it mean, though, if if y is 0? But what did y represent? Let's see. Y is the number of hours walking. Okay. Let's say she didn't spend any time walking. Today, she's going to run this thing. So, you'd put a 0 in for y. How many hours would she have to run? What was x? It was 2. So, it sounds like the intercepts represent the time it would take to just run, or, as we're about to find here, the time it would take to just walk. So if we're just walking, we would set x equal to 0, because x is the number of hours running, so let's make x 0, and then that'd be gone. Divide by 2, y would equal 4. You'd have to spend 4 hours if you're just walking. So let's see how they word this here at the bottom. What do the intercepts represent? The x-intercept represents how many hours it would take if Pamela runs the entire time. The y-intercept represents how many hours it would take if she walks the entire time. Okay, cool. And with this graph right here that they make of this line, walking, running, you could say, if you're Pamela, you could be like, man, I'm kind of tired today, but I don't want to just walk the whole way. I want to do a little bit of running, so like maybe right here. That would mean, you've got to do half an hour of running, and you've still got to do 1, 2, 3 hours of walking. Half an hour running, 3 hours walking. Because this is 0.53. That's the coordinates there. 3 represents the walking time. Half an hour, half represents the running time. Make sense? All right. I believe that's all. Let me just take a quick look here. So to recap, you are going to set x equal to 0 to find the y-intercept. You're going to set y equal to 0 to find the x-intercept. Once you can graph those 2 points, where the y-intercept, where it intercepts the y-axis, the x-intercept, where it intercepts the x-axis, you got 2 points, you can draw a line, and you've graphed it. Well done. You should be good. We'll see you next time. I say that every time, don't I? We'll see you later.